why it was so difficult. At the beginning, you just had your commodity hardware, you just buy some really cheap disk. You've got all these open source software, right? All these animals, basically. You've got Zookeeper to maintain all them together, but it's really difficult to set up. Some version of Hive wouldn't work with some other version of HDFS and things like that, same for Pig. So you need to find which version of which tool works with the other version of another tool. Every time you upgrade something, you have a risk of having your entire cluster being down. So it's really complex to maintain. And so some people saw that it might be easier to just sell some enterprise version of that. Enterprise distribution, just like Linux got some distribution, different distribution with different packaging basically on top of it. And the main three are Cloudera with CDH, Hortonworks with HDP, and MapR, right? Jeff, anything you want to add about these distributions?
Yeah, so I mean, I would say that, to Jerome's point, the first attempt at setting up any kind of Hadoop environment was always this first thing that's on this slide here, which is commodity hardware and an open source installation. People did it themselves, built it themselves. It was pretty popular. I've worked with some really big name customers, especially in like finance, insurance, things like that world, that weren't interested in buying these technologies. They wanted to build their own implementation. It became super expensive. And then to Jerome's point, you had these three big players. So Cloudera was considered the more enterprise version. So it was considered the more like polished, enterprise ready, less flexible, right? But more like secure, more and way more expensive, right? That's kind of the Cloudera's situation. And then they focus on enterprise use cases. Like Impala is like designed for the enterprise, right? Like high speed query across high volume data for analytics. That's an enterprise problem all day, all night, right? Like some of these smaller organizations don't have so much data volume, so they didn't care about having this big engine that could query fast, right? Hortonworks, known as so Cloudera was known as CDH, right? The Cloudera, I forget what it stands for, it doesn't matter, but CDH was their product, right? HDP, the Hadoop data platform, or the Hortonworks data platform, that's Hortonworks offering. And they are much more driven by the open source. So Horton is all about embracing open source, not building so much proprietary stuff on top of what they're building. And so a lot of their model for making money was like support contracts. So we're gonna, instead of giving you a version of, like Cloudera would be like, here's Cloudera Hive, LOL. We'll support it, we'll do everything, but you're using Cloudera Hive, right? Hortonworks was like, we're gonna give you real Hive. We're gonna give you like open source Hive, but we're gonna give you support for that. So if something goes wrong with it, we'll help you. Well, what that did was it allowed people to be more on the cutting edge. So like if you had a data science shop or a smaller shop that wanted to, leverage newer versions of these open source, like you gotta remember, a 90-day life cycle would be insanely good. So that's what Cloudera like tried to stay within, like 90 days to 120 days or something, 3 to 4 months of these new product releases. Horton would be like, dude, just drop anything in there, we'll support it like tomorrow. And at this time in the evolution of these products, it was very, very fast that people were innovating, right? So these, somebody would check in some amazing feature on like a Thursday, and by Friday, somebody at Hortonworks could be leveraged. Somebody that was using HTTP could be pulling in those libraries and using Horton support to like leverage it. And Cloudera is like, we're not supporting that until we pull it in, we test it, and we'll drop it to you in 3 months. That's kind of the difference between the two. And then MapR did their own thing. They wrote their own. They to their credit, they did a lot of really innovative things. But a lot of what they did was completely proprietary to MapR. They had their own storage layer. They had their own, versions of a lot of these tools, and it was very performant for certain use cases. And there's still MapR customers out there today, right? Yeah. But we, one thing I did want to mention that we do saw, I mentioned it earlier. The Cloudera and Horton did merge, so they performed a merger a couple years ago, and so a lot of the products that they both, because there was Sentry and Ranger did the same thing, right? Impala and Spark SQL did the same thing. You had these different competing technologies that did the same exact thing, and for that they kind of culled these out, right? So they got rid of Sentry, kept Ranger, got rid of this, kept that, right? So they've gone through their portfolio and cut out the duplicates and picked kind of the best one moving forward. And that's their new, they called it something weird off rip. I forget what it's called. It was a cool little name that they called it. And now I don't know what they're calling their new offerings, but they're highly partnering with cloud vendors, right? That's their new approach. And they're trying to take this Hadoop concept and make it work on, make a lot of these things work on top of S3 based object storage network file systems, right? Like that's the future. They understand that, and that's where these new, that's where these companies are kind of moving.
And we'll discuss that next as well, because we see that everyone is doing that, right? But then after this community hardware era that we've seen at the beginning, then we realized that, well, community hardware is nice, but it's difficult to maintain yourself. It's not always the best hardware either for what you're doing. If you're buying different kind of disk, it's not that easy to operate. It's better if you've got the same hardware for everything. So some engineer system came in. For instance, we at Oracle sold the big data appliance, which is a package with both your hardware and your software. We were working with Cloudera on the BDA, so you had a specific Cloudera modified for the big data appliance, and that way when you tie the hardware with the software, you've got a much integrated experience. You know that everything will work because it's designed for it, right?
Right, and I think we should stop for a second. So Matthew, do you have any other questions? Because I know you have a hard stop. So let's go ahead and do questions if you have any, and then Jerome and I will go ahead and finish out the presentation.
The question that I had was around what do we do at Oracle for big data?
Right.
So was...
Okay. All right. Well, I think it's okay. We can let you go now, and we'll talk about that here in a second, and we'll share that with you after. And so I just want to say thanks so much for joining, and I know you have to hop off to another customer call, and we don't want to keep them waiting. So thank you so much for joining the podcast. It's been awesome, and we'll have that conversation around that next question here in a second, and we'll share that with you.
Thank you, Mathieu.
Sounds good. Thank you. Thanks for having me.
Bye.
Yep.
All right. Absolutely.
Very enlightening. Thank you. Bye-bye.
All right, so I wanted to add something to the big data appliance as well, which is that it was also highly tied to Exa, right? And I think there's technologies like Big Data SQL that were really the precursor to a lot of really important, technological advances. A cloud SQL layer is the same thing as Big Data SQL, right? Taking data and doing SQL queries across multiple, sources and multiple cloud sources is the same thing as doing it in a distributed environment. Leveraging something like SmartScan and all these other technologies under the covers of Exadata onto another technology is another thing that's very popular.
Yeah.
I've seen so that's something that you always need to shout out.
Definitely,
because BDA really paved the way for a lot of these for Oracle customers.
Yeah,
for sure.
That's the first iteration of an actual lakehouse, actually, where you've got your lake and you've got your data warehouse, and you can federate these two in a lakehouse.
And they're super tightly coupled, and they can talk to each other. Very performant, right? Like it was huge, right? And then native cloud deployment. So the last one is. This is a little bit of a touchy subject because we've seen so many failed services. So Oracle, I'll be the first to admit, we've got big data services out our wazoo that didn't make it. HD Insight, all these other, IBM had failed stuff, Microsoft had failed stuff, Google has had failed stuff, and when Google fails, that's how you know that it's hard. So this native cloud deployment is that topic I talked about earlier, where finding the right mix of customer ownership with the cloud vendor providing administration, finding that right gray area is always been a problem, right? Because have a certain amount of customization you want to do as a customer, and to do that you need to have access to the cluster. But if I give you the access to the cluster, are you going to break something? Are you going to install IntelliJ on a name node, which I've seen?
Right. So definitely you need to decide if you want to operate everything yourself, or if you want to give some control but have something easier and focus on development. And both approaches are valid for different use cases. Some people want to have the access to everything and make sure that it's exactly how they want it and tune it. Some people want to have a service that is prepackaged and easier for them. And I think some of the cloud vendors have different offers, right, where you can decide which level of complexity you want, which level of prepackaged solution you want.
Yeah, I know Google still has like an out of the box Hadoop cluster that you can just spin up and then just send jobs to like these ports that are preset for Hive or whatever, right? But the amount of customization is zero, right? You can't go in there and change anything. And that's the big problem, is finding that way to allow customers to take full advantage. You know, people that are, your biggest problem is this. When you're talking about Hadoop, you have two customers. You have, I'm already running Hadoop and I want to run it in the cloud cheaper. And then you have, what is Hadoop? Let's watch this podcast, right? If you have the already running Hadoop customer, they're almost impossible to host because they're going to have so many tweaks and tuning things and like custom things that they're running in their cluster that for you to support all of them as a vendor is so hard, right? But then if you have the I don't know anything about Hadoop customer, then but you're giving them these responsibilities to administer this thing, they're going to fall into the same pitfalls that all these other people have fallen into for the last 15 years around administering their cluster, like putting IntelliJ on their name node and then not knowing why their logs filled up and their name nodes crashing and their whole cluster is down. Well, you can't put graphics drivers onto a Linux name node and then have IntelliJ dropping tons of log files into your tiny little like slash storage area and then expect not to have problems, right? But they didn't know that. They just thought, hey, the best thing for me to do is install a local IntelliJ instance here so I can do my development, right? So that's what you run into, and I think that's why it's been so hard, and that's where we've moved on. I think as an industry, we've moved on from Hadoop, right?
Yeah.
Now the focus is on these standalone tools, these elastic standalone serverless, you know, you hear that all the time. This serverless type of technology where it's like, I don't have to manage all this stuff. I don't have to figure out why my name node's dying, whatever. Just spin me up some resources on demand. Let me run mostly Spark. You know, Spark seems to be the winner here across the cloud vendors, right? Let me run these Spark jobs, these real-time jobs, these streaming jobs, these batch jobs, these Spark SQL capabilities, whatever it is. And then when I'm done with my work, I spin it down. I don't care. I don't have to worry about security. I don't have to worry about maintenance, administration, logs, file filling up, anything like that. I just run it, spin it down, done, right? And that's really where the native cloud direction has started to head, I feel.
Yeah, exactly. Well, you know me, I like it when it's simple, and it's a lot simpler to just use a serverless service than maintaining and operating your own cluster, right? So that's what I like. I like developing Spark jobs because it's just easy. It's just what I like to do, data integration.
All right, well, let's spend the next few minutes here talking a little bit for Matthew so he can watch later about how this all fits. You know, where does this fit in the Lakehouse pattern, for example, right? That most common thing that we've talked about.
Sure. So the Lakehouse pattern is something that everyone is discussing, right? Everyone has its own vision of it, but basically what it is to use object storage where you put all your data in and then you access it with a lot of different tools. You can have a database on top of it and things like that, but you store all your data in a lake, on Object Store or Amazon S3 or something like that, right? Because that's cheap, as we said before on the first slide with all the different tools, we see that object storage is cheap. You can have a lot of data. Even if you don't know yet what you're going to do with this data, you can just land it on object storage and figure out later, right?
Right, and you know, like when we're looking at a architectural diagram here of the Lakehouse, and you know, at the center of all the capabilities is storage. Just like we started with storage in that first set of the conversation, we now kind of cycle back to what are we doing today? Same thing, right? So I think the two most popular concepts today are that Delta Lake or lake storage layer, which allows you to do CRUD operate, like the biggest idea there, upon many other, certainly many other features. But the big feature that you see there is the ability to do straight database CRUD operations against flat files that are sitting in object storage, S3 object store, buckets, that type of storage layer, right?
Right,
and then you just see vanilla.
Just as that context, CRUD means create, read, update, delete. So insert, update, delete, and select statements directly on your files, right? So that's what a lake is supposed to do.
And generally, we're able to only do selects off of those. You can certainly build a layer, like with ADW. I've seen customers that have built out the capability to use external tables on top of files, so they can do inserts, they can do deletes, and they can read, but they can't update anything very easily, right? Because then you're having to pull in and out, right? So they can write to the underlying object store buckets, they can read from the underlying buckets, they can delete things out of there, and then their tables will be updated. But to go through and update records, that's the update upsert is definitely the challenge. And and it's obviously a huge part of any data warehouse, right? So when you try to run this like raw data warehouse directly against your object store, which is what everyone's dream is, right? That's the Databricks dream, that's the Oracle Lakehouse dream. That's a challenge, and so that's where the focus for a lot of the innovation has been, is around that storage piece. And then we have managed open source. So when we talk about that, that's right down the alley of these big data technologies, right?
Spark mainly,
Things like Spark, things like managed Hadoop. I mean, I don't think managed Hadoop is dead. I think that there are on-premise customers. I think there might be more labels too in this animation.
Yeah, there is. So that's the product that we have, right? For managed open source, what we have is Big Data Service, OCI data flow, and Search Insights.
Right. So again, we have you have this open source category where people are leveraging these Hadoop style things. And like I said, I think Big Data Service from Oracle, I think that Google's Big Data Service, I think they still have legs, because there are on-prem customers still today that are a little bit behind the maturity curve, that want to just run this stuff natively in the cloud. And we have BDA customers still out there, for example, that eventually are going to want to move off of BDAs natively into Oracle Cloud. And I think Big Data Service is a wonderful landing point, for a BDA customer, right? When we talk about data movement, you have tools around that. Spark, another great data flow, another great data movement tool that's based in part of this this type of technology. And then Jerome, I'll let you comment on OCI DI.
So the OCI data integration, that's a full UI tool where you can design your flows, and it's also a Spark serverless service, right? So if you don't know Spark, you don't want to learn Spark, you just want to drag and drop your sources and a filter and an aggregation, you can just design that in a web UI, and it will generate Spark jobs for you, run it in a serverless manner. It can actually run that on OCI data flow. You can scale it. It scales really well. It's just what you want. You don't learn Spark, but still you can leverage all that and run your job in a distributed fashion, without having to operate any cluster, because it's serverless. You don't actually have this a server for you. It's just when you hit the run button, there is something that is provisioned for you at the time of your
when you look
job
at
running, and then it's gone.
And when you look at the real-time aspect of this, you got the same type of story, right? You have Golden Gate with Kafka, which we talked about a little bit earlier. You have OCI Streaming, which is Oracle Cloud native service that's built on Kafka APIs, right? So Kafka, again, coming into the story of Lakehouse, right? So that data movement piece. I mean, this Lakehouse pattern really maps directly to what we've talked about today from these big data technologies. And there's big data technologies that play a role in every one. Metadata management, right? Data definition and discovery are for Oracle. From an Oracle perspective, that's our data catalog. Data catalog highly, very tightly coupled with object store, with OCI Lake, with autonomous data warehouse, with plans, roadmap plans to couple with data integration, so that we can do
with data
lineage
integration,
and
with OAC. So the
right,
goal here is
OAC.
to define a business glossary for all your data sources, and just manage and govern your data in a central point within the entire OCI ecosystem. So everything you've got in OCI will end up.
And from a big data
catalog.
perspective, what's the core tie-in point? Hive,
Yeah.
right? Hive Metastore drives the definition of data flow for data catalog. It drives the definition of OCI Lake for data catalog.
And you'll find
it drives
that
the
in
definition
catalog,
of anything from BDS from data catalog. So you see these big data technologies still being a key component in all these capabilities that we're talking about.
And I think data governance is really important when you've got that many tools. In a lake, you can have different tools doing different things. So having data governance somewhere is really important. So I'm glad data catalog is there. You can do lineage to see where your data comes from where your data comes from, so where it goes. So if you've got a dashboard, you can see where it comes from. That's really interesting, I believe. Yeah.
Absolutely. And then the last piece is warehousing, right? And we have ADW, which is ADW. We didn't mention ADW as one of the big data plays, but it truly is in that same category of like a Hive, right? So obviously historically it wasn't there because it didn't exist, right? So it wasn't part of the history of big data, et cetera. But ADW has now become a modern way of solving that Hive problem, which is building external tables directly on top of object storage, adding security, adding user authentication, role management, data access, high performance query across unstructured or semi-structured data. You can do that today out of the box with Oracle ADW in a performant way that scales, that's cost efficient. It does a lot of what we're talking about and what we did talk about from that serving / query layer can be handled against these big data sourced items in object storage or even OCI Lake from ADW, right? And I think that is a key takeaway as well, that as database has gotten better, right, as the technology around Oracle database, and Redshift does something very similar to this. So it's not just Oracle that's innovating on these things.
But it's impressive. It's impressive how much effort and progress we've done in the last 5 years around parsing JSON files, for instance, or something like that. It's just so easy now, and you can directly join your JSON data with some actual table into ADW or something like that. It's just so easy to use now. So
I've worked with customers. I've worked with so many customers that are doing this ADW pattern where you have OCI Lake, your lake in OCI on Object Store, just vanilla Object Store. You create ADW tables on top of these Object Store layer to give you that security, that user management, role access control, all those good things. And then you just run data flow jobs or BDS jobs under the covers to do all your transformation, landing it in multiple landing zones, and then manage your entire data warehouse directly from your lake, right? And we've seen that for sure.
Yeah.
I did want to take a step back because we didn't talk about OCI Lake too much. We kind of breezed over it. I did want to mention that is a new product that is coming out. It's currently in limited availability, but Oracle is, let's talk a little bit about this, right? So let's talk about Lakehouse versus Lake a little, right? So Lakehouse is a pattern, right? So Lakehouse is a pattern where we can, leverage all these different things, your sources, your data warehouse, your data movement and ETL layers, your data science and AI, your metadata management all lives on top of your Lakehouse pattern, right? The difference between Lakehouse and Lake is a technology that's very specific to your storage layer. So did you want to talk a little bit about, the Lake product, Jerome, and kind of what that brings to the table?
Yeah, sure. So the Lake product lets you mount buckets, so object storage bucket, and that's called a schema. So then people can access all these mounts. They can have schemas. You can see the file there, or you can also create tables on top of that, right? So that's easier. You can already structure the data and basically pass it. So that makes it easier for other tools to access it, right? So yeah, this is something that will evolve over time, but it's really promising. So it means you won't need ADW if you don't have ADW, for instance. It could be a replacement. It will also let you do CRUD operations on it, so that's great. Currently it works with big data service, data flow, data integration, data catalog. It's evolving really fast, so I'm really excited
OAC as well. Like
yeah.
you can connect with OAC.
Yeah.
So yeah, so it's a lake. It's a storage. I guess you can think of Lake as a, next iteration of innovation on top of just vanilla object store. That's going to add more fine-grained user access controls and other things in the future. We talked to product management about Delta Lake. Things like that, supporting the Delta Lake file format, for example. So those are all things that are coming. So it's a real exciting. It's a real exciting addition to our Lakehouse story, for sure.
It is. And then we've got the data science side of it, right? So we have data science, OCI data science, where you can have notebooks. It actually now integrated with Dataflow as well, so that's really good.
You see Dataflow integration there with Spark. You see the Spark stuff that they run for Spark ML, right? Like you see all that stuff as well. So arguably not the greatest tool, but it's still a way to do some of this stuff. So it's really cool to see this kind of Lakehouse concept, and we're talking specifically to Oracle products today right now, but when you look at this across any of the vendors, it's the same story, right? These big data technologies were the grandfather of all these ideas, and a lot of the residual effects can be seen by things like Hive Metastore, things like Spark being involved in a lot of this stuff. And the basis of all storage that we have today is still based upon the original ideas around HDFS. So it's been a really cool journey to see this big data thing kind of go through this Hadoop thing, I would say, right? The Hadoop big data piece go through its iterations and end up here.
It started with a lot of different projects and some headache to find out which one you should use, right? But now most of the cloud founders, they have a really good story with a defined set of products that build these data lakehouse solutions. So everything is integrated, it works together, and that's easy to do now. And you don't have to operate your own cluster. So I think that it's fantastic where we arrived, seeing from where we started and where we are now. I think I just like that story.
And it's exciting to see where we're going to, right? We can already start to see a lot of cool hints there. So I guess on that note, we can go ahead and wrap up. I hope that you guys found this to be helpful, this kind of conversation around the history of big data and kind of our way of encapsulating what big data has done for everyone, where it started, where it's going in this new cloud environment, and then how Oracle is kind of leveraging these in one of the most popular patterns that we see out there today, which is the Lakehouse pattern. So big thanks to Matthew for joining us. He had to jump to a customer call, but super great to have him on and asking some questions. And Jerome, thanks a lot for joining as well. Your insights are always super valuable.
Thanks, Jeff. Thanks a lot. Thanks, everyone.
Absolutely.
Bye-bye.
All right. Well, thanks, everyone, and we'll see you on the next episode.